Can I start, or you start recording already, or?
Yep, sorry, the recording started. Feel free to start. Sorry.
Okay. Okay, so thank you for coming to the LoopBack session. So we're going to talk about the LoopBack, which is a open source Node.js framework. So let me introduce myself. My name is Dinah Lau, and I'm one of the LoopBack maintainers. Together with Rifa and Raymond, we're going to talked about LoopBack in this Innovation Day. And besides that, I'm also a development manager at IBM for API Connects on the cloud. You can find me from those Twitter, email, and those information. So if you have any further questions afterwards, then feel free to contact me. So now is about you. Initially, I was thinking maybe we can get some more interactive sections to talk about, to ask you like what is some of the background, and but I think I got some of the information from Tom. That's I think most of you has experience with Node, JavaScript, or TypeScript on a daily basis, and some of you have heard of LoopBack before, and which is good. So today we're going to talk about, so I will talk about the high-level overview of LoopBack, and Rifa is going to talk about how to extend LoopBack, and then using one of the examples that he is working on. And last but not least, Raymond is going to talk about, like, besides LoopBack, you can create APIs, and you can also use it as the foundation to build a large-scale Node.js application. So he will show you how to do it and some of the tips. So before I get started, and I would like to share your exciting news that in last week's OpenJS World, there's an announcement that LoopBack joins OpenJS Foundation as the incubation project, and which is a very exciting news for us and also a major milestone. We've been always moving towards the open governance, which is very important as an open source project. And I think as we're growing more users and also more external maintainers, and I think it is a natural steps for us to join the foundation. And I also have the link at the bottom of the slides, and you can also go there. I've shared the slides to Tom, and so I think you'll share it after the events. So what is LoopBack? So LoopBack is a open source Node.js API framework that allows you to create API very quickly. We have out-of-box integration with more than 20 databases and services. So, for example, for most of the popular database, you find like Mongo, Postgres, and maybe Cloud and MySQL, and also services like I think not a lot of framework will allow have the out-of-box capability to help you to connect to SOAP services, which is more legacy service, and of course you can also connect to the REST service as well. And you can also use LoopBack to integrate with your other IT infrastructure for security and storage. So if you see the picture at the bottom, so the API creation part is for the sort of the API developer persona, and for the extension, you can build different extensions to talk to different systems. So for example, like for LoopBack is sort of like a smaller core of the framework, and there are some built-in extensions you can use, but you can also create extension on your own. And so say if you want to connect to LDAP, and you can also like create an extension to talk to the LDAP system that you have. And then the last part is the sort of for the platform developers, like how you can use LoopBack and to build a larger scale projects that is easy to maintain and able to scale. So to give you a more example, this is one of the examples that you can use LoopBack for. So one is the open is an online shopping example. So I think a lot of you has started more of the online shopping these days. So usually it's like you go to a website and there is some a product catalog, then you can choose what to buy, and then you can put things in your shopping cart. You can log out. You can log in to find out what is your order history and things like that. And so what underneath it is like usually not everything is coming from the same database. So in my example, it's just an example, right? And you say your users and order history are coming from MongoDB, and we have connectors for that to help you to have the interaction very easily. And for example, the shopping cart could be another data source like Redis. And it's not only for a database, right? And say there's some recommendation service, or there's some review service that is in REST or in SOAP, and we also have connectors for you to connect to those external or third-party services. So once so on the right side of it, you're able to interact with the backend resources, and sort of towards the left side of it, and from those you can create different endpoints, the APIs, REST APIs or GraphQL APIs. Then you can so that others can interact with your application. So once you have those APIs, then it becomes very easy. That's like it could be someone else calling your API, or you can build a front end to call the APIs. And the choice of front end, then it could be anything, right? So you can make your own choice. That it could be React or Angular and those things. So in here, like inside the application, the application I mentioned, there's the database connectivity and the service proxy, and then like inside the application, you can put in your API implementation. Maybe before you put in the database, you want to do some validation or to do some other manipulation before putting into or talking to the backend resources. And of course, you probably want to add your security layer for your APIs, like the authentication and authorization, and throughout the whole application. And you can also add in the observers and interceptors. So for example, for the application lifecycle, when the application starts, you want to put some logic in there, or maybe when the application stop, and then you want to maybe you want to print out the logs, or maybe it doesn't stop successfully, then maybe there's something that you want to do. And for interceptors is like you can listen to different events. So for example, if someone calls this user API, and so someone called the user API to log in or to create, then maybe for some of the use, you can create an auto log, and so that you keep track of who log in and when, or who log in and do what, right? And so that's the interceptor, the usage of the interceptor. And of course, after you have created that and you want to deploy your application, so after you test it and run it locally, and we have the API built-in API Explorer that you can test the API very quickly. And you can, there are different ways to deploy it, right? One is you can deploy the IBM Cloud using the Cloud Foundry, or you can use a more cloud vendor agnostic approach to deploy to Kubernetes clusters. And just a few days ago, I was doing that and pushing that to the IBM Cloud Kubernetes cluster. And so it's a very simple way to do it. So if you want to get started today, and I would suggest you go to this demo just to walk you through step-by-steps. With 5 commands, you'll be able to have a very simple application up and running. So basically, you create the application, scaffold the application, which provide all the project structure and stuff. And then to create your model, which is your business domain objects, which usually maps to your database or some sort, and then you create the data source, which is actually the connection to the database and or the services. And the next step is like for LoopBack 4, what we've done is to separate the model from the data source, meaning that's like you can have multiple models that talk to the same the multiple model for the same data source, or there's one data source and then one model, and depends on what is the usage, you can dynamically connect to the different data sources. And so the repository object is the one set to bind the two together. And the rest, the next one is to expose the REST APIs. We have the CLI to create the CRUD operations for you by default, and you can choose that option, or you can like add on your own REST APIs options as well. So and then after that, and after you have it up and running, and we have, as mentioned before, there's an API Explorer for you to test. And so it's like it lists all the endpoints that you have in the controller, so you don't need to guess. And it's a very convenient way for you to do some unit testing on that. We also have some in the documentation. We have some information on how you can write your automated tests, so you don't need to always use the API Explorer. So if you want to get started today, and feel free to go to this link. This is the first to-do tutorial, which is a very, very basic app. And if you look at the documentation for there's a set of tutorials. And so one is like very basic one. And then after that, what you can do with it is, for example, you can add model relation. So for example, if I'm the user, I can have a shopping cart, or if a user can have multiple shopping, like order history and things like that. And then go one step further, you can add how you can add the security, how you can use the GWT authentication to authenticate. So it's also covered in, like, there are different tutorials in there. So now you might wonder why LoopBack. You probably get some answers already. So we have very like a comprehensive REST API experience, and with Open API, and we can talk to backend resources, but we can also create the REST APIs and GraphQL API for you to call. And we have out-of-box integration of most of the popular databases and services with different connectors for it. And in LoopBack 4, it is a totally new core that is written in the TypeScript for better maintainability and scalability. We introduced the concept for dependency injection and extension point patterns, so that it makes the framework is much more flexible and extensible. And one thing I haven't talked too much about it is there's a instant GraphQL gateway from the REST APIs. So we're using there's a module called Open API to GraphQL. So once you have that REST APIs, you can quickly also have the GraphQL gateway as well. But if you don't want the two types of API at the same time, you can also make use of one of our GraphQL extensions that can create the GraphQL APIs as well. And we have a good a cloud native deployment experience. So you can also, there's some documentation for you to follow that. And last but not least, and about in 2009, we have an award from the API World. We received the award for the best in API middleware. So which is a good validation that's like our framework is architecturally sound and also have a good level of popularity that people are using it. So in terms of our users, so here's the list that's the user reference that we collected. So some of them approach us that, oh, I want to be showcased in our website. And so we are expanding the list right now. If you want to see how they're using LoopBack, you can go to this link. So that's pretty much it. And so I would suggest to connect with us. So our Twitter is more active and than the Facebook and the LinkedIn, and so you can follow us on Twitter and also join our Slack workspace. And this is where our community is helping each other out. So you have any questions, or maybe just wants to help others, and so you can join that workspace and post your questions and interact with the other LoopBack users there. So that's it for me. Any questions or?
Thank you so much, Diana. That's a really good introduction to LoopBack. I do have a question. It's a bit of a weird one. Is there any scope for LoopBack to support Deno in the future, being that Deno sort of like basically runs off TypeScript?
Not in our initial plan, but we are open to, if you're interested in it, and we can always work together.
Awesome, thank you.
Okay, so thank you. So so maybe I can pass the time to Rifa.
All right, thank you so much, Diana. Are you all able to hear me fine?
Yep.
Okay, just need to share my screen. All right, are you able to see this slide just fine? Okay, great. Right, so hello everyone. Thank you so much for joining this talk. And so today we'll be actually just talking about how to extend LoopBack 4. This is more of a higher level overview of what you can do in LoopBack 4, like what are the utilities and concepts it provides that aid in building extensions for your own projects. And then after that, we're going to look into one of our existing integrations that we're currently working on. In this case, integration with Prisma.js. So just a quick introduction about me. I am Rifa. I'm a LoopBack 4 maintainer. I've been a maintainer for about 1.5 years now. And I'm not part of IBM, but so I am actually from outside, and I've been contributing back to the project because my own organization actually uses LoopBack 4 quite extensively for many internal projects. If you'd like to contact me, I'm on all of those social media, as well as GitHub and LinkedIn, or you can drop me an email as well. So in this talk, this is just a rather high-level overview of what we're going to be talking about. So first, I know Diana has gone through what is LoopBack 4, but in this case, I actually want to go a little bit more deeper into what actually builds the framework, so that we can understand and how we can actually fully leverage its modularity and extensibility. Then we're going to look into picking a layer. So extensions can actually extend different layers in LoopBack 4 because the frameworks are actually built in a hierarchy of packages that are actually built on top of each other. So picking a layer can actually help us understand the scope of the project, and it can help us know what we should extend or what we should potentially spin off as a separate package. Next, we're also going to be talking about dependency injection. Dependency injection is starting to become quite well accepted in the TypeScript and Node.js community as a whole. So LoopBack 4 definitely has its own dependency injection framework, and we'll discuss how they can benefit you as extension developers and also benefit the extension users. Then we're also going to go into components. So components is a higher level concept that actually helps kind of like wrap all of these artifacts that your extension provides. And we're going to see how they can actually provide an abstraction layer to make it easier for users to get started. And finally, after all of that, we're going to discuss why should you write a LoopBack 4 extension, right? What can it bring to the table compared to a regular Node.js require or a ES module import? So what is LoopBack 4 really, right? It is typically thought of as a REST framework or as a REST middleware, though I think it's good to see it more like a meta framework. It is considered like a collection of packages that work really well with each other. So it does provide higher level abstractions, things like servers, services, lifecycles, etc. And it can go higher into REST in GraphQL or the ORM as well. But it's important to note that all these higher level abstractions don't necessarily require a specific or assume a specific protocol. So for example, dependency injection doesn't depend on REST. You can still leverage LoopBack 4 in your own projects, even though you may not be building a REST API. So by considering it as a meta framework, as a framework that can use it across many projects, you can probably see how this can actually help with providing a consistent code base. Because as you know, every new project that you spin up, there's usually a new design philosophy or way of writing code. And usually what happens is that developers end up rewriting higher level abstractions for each new project, or they use different packages that different competing packages that try to solve the same issue, but in their own way. So we're going to see how LoopBack 4 can provide that level of consistency in a homogeneous ecosystem. And I think this is the most important part. And what really sets LoopBack 4 apart is that it is unopinionated. Unlike other frameworks out there or other packages, LoopBack 4 doesn't really assume how you want to use the APIs. It doesn't assume what kind of APIs you want to access, what may be off limits. So with LoopBack 4, we actually try to expose as much of the API as possible so that you can gradually ease yourself into the framework. But then as you start to grow your project, you are not limited or hampered with the framework. So that because typically what happens is that as developers continue on a project and then they find a certain need for more complicated or more weird kind of requirements for the project, they would typically need to resort to working against the framework because the framework makes certain decisions on behalf of them. With LoopBack 4, we don't really do that. We do provide higher level abstractions, but we don't restrict them arbitrarily. So as mentioned before, LoopBack 4 can build web APIs such as REST, GraphQL, and Socket.io. We have all the packages to build that, most notably REST. But also, you can use LoopBack 4 to build almost any enterprise Node.js or TypeScript projects. And it'll be a little bit more apparent in a while, but if you are able to actually incorporate LoopBack 4 in other projects as well, you'll be able to actually reap even more benefits from the reuse of the same set of packages. So essentially what I want you to take away from this is that LoopBack 4 does REST APIs really well. There is no question about it. It has an absurd amount of packages that is specifically tailored towards REST. But it can do a lot more. Along with all the REST packages, you have other packages like the ORM, the dependency injection, the LoopBack core. All of these don't depend on REST, and they don't assume that. So you can actually reuse those packages and the concepts that they bring forward in other projects as well. So now let's move on to picking a layer. And what do I mean by picking a layer? As mentioned before, LoopBack 4 is built as a group of packages in a homogeneous ecosystem that tend to build on top of each other. Now, this isn't a comprehensive diagram of all of the packages. We have plentiful more, but I think these are the main ones that most people are familiar with. So in this case, you have the dependency injection package right at the very bottom, followed by the core package, which adds higher level abstractions, followed by some more protocol-specific packages like REST, GraphQL, and also Open API validation, which builds on top of REST. So as mentioned before, all these things build on top of each other. So you can see how some of these packages are scoped, and you can know what they do and what they don't do. And this is really useful for modularity. It also builds on a top-down approach. So for example, the REST package depends on the core package, which depends on the context package. So if you're using or writing an extension for the REST package, you can actually be confident in that you are able to leverage the same benefits of the core and context package. So this provides modularity, and it also provides a well-defined scope. As mentioned before, if you know what your extension needs to touch, you would reduce the likelihood of scope creep. and a potential tech debt, and also potential grid lock resulting from certain assumptions being made. And because of that, we are able to actually make your extensions a little bit more extensible. So for example, if I'm creating an ORM extension for Prisma, I don't need to depend on the REST API, the REST package, and I shouldn't assume that. Instead, I could potentially base it off the core package or the repository package if I want to. So that means if for whatever reason a developer is building a LoopBack 4 application that doesn't use REST, they'll still be able to use my extension and still leverage the same benefits of LoopBack 4. So now let's go into dependency injection. Now this is where the fun part starts, because in LoopBack 4, dependency injection is like bread and butter. It's used throughout the framework. But first, I think it's really important to understand what dependency injection tries to solve. Especially in the world of Node.js, it may not be as clear. But typically, these are the 4 main pain points that I personally have found when not using dependency injection. First is the initialization and management. So say like I need to create a Winston logger, or I need to initialize a Prisma ORM. Right? Both of these are Node.js packages by their own right, and they are all initialized in their own way. So that means if I were to bring more and more packages in to add more features to my application, I would need to learn and understand how these packages interact. And furthermore, I will also need to make sure it's well documented that yes, this is how it works, and so that other future developers can understand the code as well. And the issue doesn't just stop there. How do you manage the instance? Do you store it as a variable in the top level class? You create a global variable in the application, or do you use a state library instead? The other issue is instant pass around. So this is another rather critical thing that dependency injection touches on. So say like I have a Prisma extension that I'm creating, and it depends on the logger, say like a Winston logger. How would I pass that Winston logger to my Prisma extension? I would have to most probably initialize the Prisma extension, or most likely have to initialize Prisma, and then I would have to manually map all of the logger functions to the relevant logging APIs on Prisma. So this is the same issue of an inconsistent API, and this would be kind of inconsistency kind of surfaces to the top level application. The next part is also configuration management, where some packages may allow you to reconfigure after initialization, others may not. And the way that they initialize those configurations may be different. There may be certain quirks there, and it may eventually look a bit like a black box. Because I think it's quite a familiar experience to many when you're trying to use a new package from NPM, and then you're trying to understand how it works. And more likely than not, the documentation isn't sufficient. So you have to scour the internet and hopefully find solutions to a problem that wasn't realized by the original package author. And even if after all of that, it's not really easy to refactor, because again, all of these APIs are not consistent. So you need to so even if you create like a helper class to manage the instance of this of all of these dependents and dependencies, and then managing how they pass around, you're essentially recreating a dependency injection framework. So dependency injection essentially helps turn around the contract between your code, the extension, and the library that you're going to use, right? So instead of your code having to manage and know what each dependence depend on, instead you can allow the framework to handle that. So if you go back to the case of our Prisma extension that depends on a Winston logger, we are actually now able to just simply register the Prisma extension, register the Winston logger, And then behind the scenes, the LoopBack 4 framework will actually help match those dependencies to each other so that the Prisma instance will be able to get an instance of the logger. So that helps reduce the code clutter on your side as extension users and help move it over to the extension. So it creates a level of abstraction. So let's talk about binding now. Because dependency injection, you have what we call a binding. This is a class which has a binding key, which then resolves the value. This is what you use to resolve, say, like a class instance, in this case, like the Winston logger. And this is just a quick overview of what you have here. So first of all, you have the binding key, which is essentially a unique identifier for that binding. You have a scope, you have tags. So tags are not unique, but they can be useful for certain situations that we'll look into in a bit. And you can see on the right side, actually, is the different binding types that we support. So again, LoopBack 4 isn't opinionated on how you do things. Not everything has to be a class. So if you want to, you can bind a constant value. So that can be primitives like string, numbers, etc., or even an existing class instance. You have things like providers, which is an abstract factory. So this is useful in case you want to build the instance based on the current state of the application, or even aliases. So this is another interesting use case for LoopBack 4. So aliases is a bit of a unique case here because it doesn't actually bind a value, but instead it binds to another binding. This is also useful in case, for example, you want to leverage another binding, but you also want to add your own contract on top of it. So you want to add certain conditions without affecting the existing binding. So here's an example of how a binding may work. I know it's a little bit messy, but we'll go through it step by step. So first of all, as mentioned before, bindings have a unique key. This is what we call a binding key. So that's what the first line here, the dot bind here. So in this case, we are creating a binding with a binding key of a namespace dot my binding key. And as it shows, binding keys can actually have a namespace, which can be useful in case you want to get a collection of these bindings. So it allows you to group them together. And of course, you need a bound value. Now, it's not actually necessary that bindings have a value attached to it. Just like JavaScript, you can have an undefined value. But in this case, we've used the dot tool to actually create a constant value. But again, you can bind a class, you can bind providers, you can even bind a function if you want to. Now, the next part is the binding scope. So binding scopes are actually a useful way for managing stateful bindings. So for example, in the case of a REST application, the REST application itself can be bound to the context. So you can actually retrieve the REST application itself if you want to interact with it. Now, throughout the lifecycle of the application deployment, there should only be one instance of the REST application. And the way we ensure that is by indicating that we want a binding scope of singleton. So no matter how many times you try to resolve the binding, no matter where it's being resolved, you are guaranteed contractually by the framework that you only get a single instance. So you don't have to enforce this yourself from your own end with your own custom solution. The next part is tags. Now, it's a bit of a misleading thing right here. Tags are actually tag maps, so they're actually key values. But we actually provide a shortcut in case you just want to just add just a name for it. But this is again useful in case you want to group certain things together. For example, maybe a collection of middleware. You can add a tag saying, say like Prisma middleware. That way we can retrieve it later. Or maybe you need the tag model, so you can dot tag models, and then you can retrieve based on that tag. Now, the next part here is something a bit more interesting. It's using dot apply and extension for. We'll discuss it a little more in depth in a bit. But this is what we call extension points, and this is actually this is a more special tag in a sense because it actually uses tags behind the scenes. But what this does essentially is just provides a little thin layer on top to actually allow extension developers to tell the framework, hey, I'm able to be extended from this point. So like Prisma, you can add middleware into the Prisma ORM. So in this case, we can actually indicate in our extension that yes, we support Prisma middleware, and our extension users can actually add middleware through this extension point. Now, this is actually the more powerful thing, is that the binding itself is also can also be an event emitter. So as you can see below, there's actually a .on change. This is not the full list of things you can do with it. There's plenty of options depending on the situation. But in this case, what this allows us to do is actually detect if something changes. So, for example, in the case of like Prisma middleware, so what if a middleware gets added? What if a middleware gets added but then gets removed later, or maybe it changes? Maybe we want to support that kind of more complicated use cases where the middleware changes depending on the application state. Well, we can do it now because we are now able to trigger a callback whenever the binding value changes. Now, for operation, we also support other things like when the scope changes, when the tag changes, and many others. So that's really useful for more dynamic binding kind of like event reaction behavior, so more reactive behavior. And finally, I think what's really important is actually that bindings are lockable. So when you do dependency injection with binding, one thing that changes is that the contract between the dependencies are no longer a hard contract. So actually the bindings can change, and because you don't have that same restriction in place. For example, if Prisma only supports configuration during initialization, well, there's nothing stopping the binding from changing after the fact. With .lock, we're actually able to enforce the configuration to not change, so that the binding will remain the same, and so that there won't be any issues of like disparity between the binding value and what actually gets applied. And if we try to change the value when the binding is locked, it will actually help surface those errors much more quickly. So we're actually able to fail fast and not have like deep-rooted issues as a result of some weird edge case that wasn't covered for. So as mentioned before, we're going to go a little bit deeper onto extension points. As mentioned before, extension points are rather just specialized tags, but what they do is actually help inform the framework where can the extension user add additional features. So how does the experience feel like, right? The user uses the binding.apply and extension for a function, and that as you have seen before. And then the extension developer can then use over here on the left side the add extensions and add extension point decorators. So this way they can receive a list of the bound extensions. So there are many other decorators for extensions. Extensions view is just one of them. So you can actually use, you can actually retrieve the list as is during the extensions initialization, or you can use view in case you want to resolve it later. Or even with view, you can actually even add an event listener, so you can track when the view changes, which is actually rather powerful if you want to do that kind of more dynamic configuration. So what does this do in the end? It actually helps reduce tag pollution because we're actually standardizing how these extension points are written in terms of the binding tags. And it also helps provide clarity of ownership. Now, typically, on the best case scenario, you'll only be reading the documentation to understand how the extension, how the package works, what does the extension do in case this state happens, or what does it require, or what does it expect. Unfortunately, that's not always the case. And sometimes you have to dig into the documentation. Sorry, not documentation, but rather the code base of that package. So by using a dedicated dedicated syntax for extension points, we're actually able to actually help developers quickly identify who owns this extension point and what they're going to do with it. Next, we're going to be talking about booters. So booters is it's a rather unique concept to LoopBack 4. It has three lifecycle stages: configure, discover, and load. So a booter, if you've built a loopback or scaffolded even a loopback 4 application by default, you definitely have seen this line right here. This.booter options equals that. So booters are called when application.boot is called, and what this does is actually quote unquote boots classes matching a file glob. In this case, this booter actually supports dirs and extensions and nested, but it actually supports one additional configuration, which is globs, which overrides all three above. So dirs, extensions, and nested is actually just a convenience wrapper for the users to actually more easily see what they're writing. And the great benefit of this is that it does what I like to call implicit binding to context. So the user doesn't need to bind all of this one by one, and especially at scale, you're not going to add like 25, 50 controllers one by one. You're not going to have like 50 lines of it in your application TypeScript file. Booters also provide the opportunity to apply binding templates. So binding templates are, for example, one case is the extension for function. That's a binding template. So what binding templates do are they are actually just a function that accept a binding, and then you can modify the binding and it just returns it afterwards. So binding templates are essentially just a way to quickly do the necessary to a binding so that it's ready to be used later. And this is useful because it provides a level of abstraction from the extension user, so they don't have to worry about all of these details, especially if they're getting started. And as mentioned before, it's scalable. It helps reduce registration and import quote-unquote noise. So you don't have, if you have like 50 controllers, 75 services, 30 providers, you don't have to write 200 lines of code in your application TypeScript file. All of that is just handled by just 5 lines or even 0 lines if you want to just use the default configuration in your application TypeScript file. So that helps with code clarity. It makes it much more readable, and it should help in the long run with code manageability. And just one thing, I know some new people actually get tripped up with the .js over here. So, because what booters are is that they actually happen during runtime. So booters they're not like Webpack where it tries to put it all into the TypeScript file doing transpilation to JavaScript, but it actually happens after that. So all of the models, controls, etc., all those things that are going to get booted just gets carbon copied over to our dist folder, which is why we have the .js at the end here. So now let's go into components. So components are actually a really useful way for actually grouping all of these artifacts together. It doesn't matter how simple you try to make it, there's going to be a lot of moving parts, especially if you want to make sure it's extensible enough and can cater to as enough use cases as possible. So to help reduce that initial burden of getting started, and also to help reduce the long-term burden of managing all the artifacts, components can be used to compartmentalize that into a single class. So not only does this help make your application class more readable, it also actually conveniently provides a center location to find where the code, to find the logic where everything is bootstrapped together for the extension. So this is an example of a component. As mentioned before, it's kind of like an artifact bootstrapper. It removes away all the implementation details. It can also potentially manage the lifecycle of artifacts. We'll discuss a bit more in that when we look into some actual code. And also there's something what I like to call well-known binding variables. So if we look at the code on the left, we actually have some variables like bindings, classes, providers. So what these are actually variables that are recognized by LoopBack 4. So if you just need to statically add certain artifacts, you can just drop them in here. Or if you want to, you can actually manipulate and enrich these variables in the constructor. LoopBack 4 will just will not initialize any of this until the constructor is finished. So you can actually LoopBack 4 actually provides quite a number of ways for you to write your extensions depending on what you see fit. And over here, you can also see the dependency injection happening. So in the constructor, we have what we call constructor injection. We have the add inject. In this case, we're injecting call bindings.application instance. This is the actual application instance itself. And then we also have add config. So this is actually where we do what we call configuration by convention. So in a binding key, you have instance of say like your extension, say like Prisma. But you also need to store the configuration somewhere. Instead of creating a new dedicated binding key just for configuration, you can infer a configuration binding key by using add config. So this will help reduce the amount of clutter in terms like it will actually practically cut your binding keys in half. But it will also help make it easier to map between these binding keys. So if you see the config binding key, you will be able to identify immediately what is the original binding key it's meant for. So again, you're able to make that correlation, making it easier to manage code and also easier to debug issues. So what are the outcomes of extensions? After all of that, what do you want? What are we expecting to get out of extensions? First of all, extensions are used to create a bridge between existing packages and LoopBack 4 concepts. As mentioned before, you can write extensions for existing packages, whether it's Winston Logger or Prisma, which we are doing right now. And by bridging that gap with LoopBack 4 concepts, we're able to encourage knowledge and code reuse, because we are actually creating a level of abstraction and we're creating a sense of familiarity. Because again, you're familiar with dependency injection, you're familiar with providers, and across different projects, it will look the same, more or less, and you are able to quickly pick up like what the application is trying to do. So this provides a level of consistency in registration, configuration, and management. I think we've already discussed this. It just manages the whole life cycle for you. And of course, as mentioned, it allows code and knowledge reuse across projects. And overall, this helps reduce tech debt, right? Because you're not redoing the wheel. This has already been done for you by LoopBack 4. You can be rest assured it's been done for you, and it's not going to hamper your ability to extend it even further. As mentioned before, LoopBack 4 isn't opinionated. It just provide you the tools and utilities to work with, and then you're free to do whatever you wish with it. All of this will help accelerate developer cadence. So while a lot of these concepts, especially to more vanilla JavaScript and Node.js developers, may be a bit arcane or not well known to them, from my experience and from experience of others, as I've heard, it actually helps accelerate developer cadence in the long run, because once you're familiar with the concepts, they apply again and again across the entire project and across different projects as well. So again, you can help provide more fluidity into your development process. So that's the end of the presentation itself. And actually, I would like to actually go through the Prisma code over here. So over here, we have a Prisma integration extension that we're working on right now. And I want to actually show you the actual code and the actual documentation that we're working on, so that you can get a feel of how the user and the extension developer experience is going to be. Now, we've actually, just to be a fair warning, we've actually done quite a bit of deep integration with it. So the extension code is a bit long, but that's usually because we're trying to cater to quite a wide variety of use cases. So over here is just the quick documentation. So you can actually see, as a user, I'm able to see what features are supported, what kind of integration is there. So I can immediately see, oh, I have my Prisma models in my dependency injected. I have lifecycle integration, because in LoopBack 4, you can do initialization, start, and stop. And with this extension, I don't have to handle Prisma's lifecycle manually. And it also has integration with the LoopBack 4 logging extension. So if I'm already using the logging extension to say like pipe Winston logs into a into an existing logging infrastructure, like then I will be able to like quickly integrate that my Prisma logs directly into that. I don't need to create a custom integration for it. So this is some additional features that we have not supported yet, and this is where we go to the basic use case. As you can see, it's actually really simple. All they have to do, this is an application class, really standard, and this is the constructor right here. All they have to do is actually just 2 lines, this.configure and this.component. So as you can see, if I'm new to LoopBack 4 or I'm new to Prisma, I don't have to do any weird, I don't have to jump to some weird hoops to actually understand and try to understand like how does this work, right? So that's one of the main things we try to do with extensions, is try to make it easy as possible to get started. But nonetheless, we also provide as much extensibility if they wish to. Over here, we actually provide the opportunity for users to provide their configuration. So in addition to the Prisma client configuration, which we just pass through, we're not opinionated on like, or you can configure this part of the Prisma client, but not the other. You just allow the users to configure it as is. And we also provide some additional things. For example, this is the flag to enable logging integration with the logging framework. And we also provide lazy connect. So this is provided because in LoopBack 4 we already have an existing ORM called Juggler, and what Juggler does, one of the things that Juggler does is that it actually tries to connect to the database immediately during startup. Prisma does it a different way. So by default, we've actually changed lazy connect to false, but if the user wants, they can actually change it. So, and we can see as we scroll down even further, there's even more configuration. So over here, this is where the middleware dependency injection comes in. Instead of using Prisma client.$use, we're able to leverage the familiar concept of dependency injection and create a binding to bind our Prisma middleware to the context. And then all we have to do is actually use the sprisma middleware function. So this will actually do the magic behind the scenes to make sure the binding is correct to be detected by the Prisma client. And the user doesn't have to worry about any of those implementation details. And the documentation goes on more advanced use cases, including some more informational things like, in this case, we have like bad binding protections, which is essentially information on when we lock the binding. So if you remember earlier in the presentation, we have this concept of locking bindings, and this is useful in certain cases where you don't want to change. You don't want anyone else to change the bindings. So in this case, for example, the Prisma extension, with Prisma, you cannot change the configuration after the fact. So we are able to actually lock the binding so that we can tell the extension user that, no, you cannot change this. It's not going to work. So instead of having like a black box like where nothing happens, we're able to raise an error and say the binding is locked. You can't change it. So that will help alleviate all those issues. And this is actually the component right here. It's rather long because we are actually doing quite a lot of gradual integration for as much use cases as possible, which is how we actually provide that seamless experience for easy to use but easy to extend. But as you can see here, this is our Prisma component class. It implements component and lifecycle observer, and this is actually you may see here, this is actually the extension points that we mentioned before. So this actually tells LoopBack 4 when binding the component that this component is expecting this extension point. And by using an extensions view, we're actually able to create a context view, which allows us to retrieve values when we need to, and actually listen to when, say, like a new middleware gets in or middleware gets out, or something else changes. So we're able to react to the user's needs. So the next part actually I want to talk about is actually the lifecycle observer. I didn't have it in my PowerPoint slides, but essentially a lifecycle observer, essentially it has the initialization at the start and at the end phase. If you've seen the application TypeScript file, you know there's application start and application stop. One thing that lifecycle observers do is that they are actually ordered. So you can actually indicate which group of life cycles you want to follow. So in this case, this component wants to be part of the data source lifecycle, which means with all the other ORMs, it will react the same way. This is also useful in case you want to ensure that something happens beforehand, like you want to ensure something else is initialized or started first. So that's one of the strong points about lifecycle observers. So we have quite a lot of code here. I don't think it's important to really go into details. If you want to see it for yourself, it's available on GitHub. But essentially, over here is the actual start command right here. So this is the part of the lifecycle observer. We actually don't do much with it. We just simply pass it to Prisma client to run the connect. And then over here at start, we call disconnect. And then just above that is actually our initialization functions. So the initialization function is actually what's doing all the heavy lifting. So this is what's bootstrapping everything together, the event listeners, the middleware registration, ensuring that the bindings are all correct. This is the part where it's all happening. Now, of course, you don't have to do all of this, right? Well, what we're doing is essentially covering the bases for as many use cases as possible. But in case your extension doesn't need to be that flexible, you can also shorten this to just a few lines as well, right? If we don't need all the fancy stuff, we can just actually do this in less than 50 lines of code. The next part I actually do want to show is actually the binding template. So over here is the Prisma middleware function. It doesn't actually do much, but it helps with encapsulating and kind of abstracting away implementation details. So as you can see here, it accepts binding, and then it immediately returns the binding. You can add more complicated logic here to get the state of the application and apply certain things depending on the use case. But this is just one of those like quality of life things that makes it just a little bit better for the user. And yeah, actually, unfortunately, the Prisma integration isn't done yet. We're still working on some additional features. But if you want to check it out, it's available through our GitHub. It's one of our more recent PRs. And that's about it. I'm more open to questions. We'd love to hear if you have any.
Awesome. Thank you, Rifa. If there's any questions, feel free to put them in the chat or just shout them out. Put them in the chat. I will shout them out for you. I actually have one.
Yes.
So with the LoopBack dependency injection framework,
yeah.
Is that inspired from any other dependency injection framework, or is it something that LoopBack sort of figured out the architecture themselves?
Okay, so I wasn't there when the decision made, so perhaps either Diana or Raymond may be more appropriate in being able to answer that question.
So, sorry, can you repeat the question, Raymond?
Yep. So with the LoopBack's dependency injection framework, was that inspired by any other dependency injection framework, or was that something that was sort of architected as a piece itself? Because obviously dependency injection isn't sort of a new concept, but it's fairly new to the JavaScript world, I guess.
Yeah, so that's true. When we start to work on LoopBack 4, and we realized we need to have a container that manages the dependencies. So we were evaluating a couple ones. Initially, we looked at the one from Angular, and we also look at the one from Inversify. I mean, both are very good dependency injection frameworks, but the Angular one was initially developed for the front end, and Inversify was a good candidate, but we realized we have many different use cases that we really have the full control of the dependency injection container. So that's why we start to write our own one, and that get evolved into a very powerful, injection framework, which has a lot of different features. And the most differentiating one is we really treat the asynchronous interaction as a first class citizen. And we really take care of the dynamic view of the dependencies. because for us, the extensibility is king, and usually we don't know all the extensions ahead of time. We don't know the configuration change ahead of time. So this dependency framework give us the ability to watch the ever-changing values or ever-changing extension. So that allows us to tweak the behavior at runtime. For example, as Rifa pointed out, like say you have one thing that takes a couple of different extensions, and that extensions can come and go. One example is you can actually add a controller and remove the controller at runtime, and our routing system will recognize that. And similarly, if you want to change a configuration like the logging level, then if you write your dependency injection using a dynamic view, you can recognize that as well. And behind the scenes, we have a cached version, and that cached version will be refreshed upon the change event.
Yeah, I think Raymond put it really well. The LoopBack 4 dependency injection framework really is kind of like written in its own beast. It has certain features that existing solutions may not have, that you may have to like architect it in a specific way. Like as Raymond has rightfully pointed out, the dynamic resolution with the event listeners and whatnot, with context views and so on. And so far, it actually has, at least from my personal experience, it actually has helped accelerate some development, because it's right there. The dynamic configuration and management of the code and artifacts is provided as a first-class citizen in LoopBack 4.
Yeah, we also heavily use a tagging mechanism for the different bindings. So we have a criteria to group different things together, which help us to discover different nature of bindings. So that give us the ability to build a middleware chain, to find the corresponding interceptors, to find the authentication strategies. Now, of course, like this dynamic extensibility heavily depends on that. And we create some sugars on top of that to allow developers to quickly create patterns like extension point / extension, which is very similar like how Eclipse plugin works. And that whole pattern was heavily inspired by Eclipse, and we were so happy we have that as a first class citizen in the core framework, which really gives the framework a lot of power. And I think Rifa sort of walks through some of the ideas as he builds up the Prisma integration. And I will cover that a little bit more in my talk as well.
Amazing. That's a really good answer. Thanks a lot for going through that. Are there any more questions? Okay, I guess that's all the questions we have for now.
So should we jump into my talk right away?
Yeah, if that's okay.
Yeah, sure. And let me figure out how to share my screen. This is the first time I use Microsoft Teams. Oh,
It's
I
a
have
bit
to
strange.
yeah, I have to change my system preferences to allow recording first. All right, can you guys see my screen?
Yep.
All right, cool. All right, hi everyone. I'm so happy to be here to share some of the knowledge about LoopBack 4. And I think Diana and Rifa has done a fantastic job to give you some ideas about what you can do with LoopBack. So for this session, we pretty much will step back a little bit and not only look at the LoopBack framework as a REST API creation platform, but kind of going back to the platform idea to see what's the power you can leverage from LoopBack to create large-scale projects in Node.js and the TypeScript, which will help you build complex applications or frameworks itself. Yeah, so I probably will give you a kind of different perspectives, how a large-scale Node.js project will look like and how LoopBack can help from both the logistic and the runtime perspectives. Feel free to interrupt me if you have any questions in the middle. A little bit about myself. And actually, I was one of the creators of the framework at StrongLoop. We were a startup at that point in 2013 that tries to build developer tooling for developers to create APIs that talks to existing, databases and internal APIs. And we feel, Node.js is a great fit for API creation for two reasons. One is, Node.js definitely is a JavaScript at the backend, and that's the closest language of a lot of front-end developers are familiar with. And mostly APIs will be consumed by, the front end. And the other thing is Node.js is very IO, traffic friendly, which will achieve a great deal of scalability. And most APIs actually fall into that category. So that's why we try to marry up the power of Node.js together with API. So that gives the birth of LoopBack. So after the IBM acquisition of StrongLoop in 2015, we continue the journey and we learn the lessons from building version 1 and version 2. At that point in time, the LoopBack framework was written in plain JavaScript, and it's very much oriented for database and the service modernization. So we use a convention-based approach to really give developers a quick way to have REST APIs from existing resources. So that works well. But we realize some developers might need to have more flexibility and more control, especially the ability to extend the framework and customize the framework so that the framework can build really powerful APIs to solve the real world problems. So that led to the creation of the LoopBack 4 framework, and we apply a lot of interesting ideas into the new framework, and we rewrite the core foundation from ground up using TypeScript. I will talk about that, why we choose TypeScript over plain JavaScript. So that's the new life of LoopBack 4, and we continue on that. And as everybody probably has known, we recently joined the OpenJS Foundation. So hopefully the next chapter of LoopBack will have the ability to attract a lot of more community developers, and we can work together to make the framework really more valuable toward your API and the microservice use cases. So I also switched gear recently. Instead of continues to being full-time working on the framework itself, I working on a crypto company. So, but the good news is we continue to use LoopBack internally to build APIs, portals, and the bots for crypto users and the tokenized communities that will interact with multiple different blockchains. So we really want to use an API first approach to make sure provide simple and universal access to all the crypto blockchain capabilities. And that works pretty well, which is also a good validation, like what LoopBack can help in different domains. So we'll continue to extend LoopBack and probably contribute some of the extension we build internally back to the community as well. So that's really a good feeling, like LoopBack has been used by many different kind of applications. Oh, sorry. All right, so I believe Diana and Rifa both mentioned like the ability of LoopBack, and I would imagine most of the audience here has already building, Node.js applications, and some of them even like create NPM modules and build frameworks. So one interesting question would be, what do you think about your Node.js project, and how would you say if a project is really a complex and a large scale project? Right? And we try to look at the different perspectives because for Node.js, you can have different level engagement. You can write a quick hello world. You can write a very simple HTTP server. Then more sophisticatedly, you can package your module and push that to NPM as a package, so all the modules can depend on that. Or you basically just write an Express application that utilize some other people's module and just add your business logic on top of that. Or you might be a very advanced user that creates your own framework that can be used by other users to build their applications. Right? So the different level of engagement and the different level of complexity will really tell a good story, like what you should be using. So a little bit look at the large scale Node.js perspectives, right? So typically there's some good sign to tell you are really working on a large scale project. You might have a lot of teams involved that work on the same project, and there are probably interdependencies from each other, and there are many different moving parts across the board. Of course, like with more teams, you will have more developers, and you potentially have more users that really leverage your project, right? And secondly, Node.js ecosystem is really promoting the idea of being modular, right? So being modular is the DNA of Node.js ecosystem. And one criteria is you can tell, how many NPM packages you're producing. Not all packages will be made public into NPM, but some companies use internal NPM registry to manage all these packages, right? So what matters is, how many packages are being developed by your project, and how many dependencies you have there. And from the source code management perspective, usually people nowadays use a popular, version control system like Git, right? And the GitHub is a good option. So one challenge usually facing for larger scale projects, like how many GitHub repos you have to use, and how you make sure all these GitHub repos work together. So that's another interesting perspective. And of course, like when you work on everlasting project, you have to maintain that project for many years, and you will create many different releases. And it requires a lot of effort to make sure you educate your developers and educate your users, so that effort to develop and maintain the project across different teams, and even across different developers people can come and go, right? So there's quite a bit of challenge for that kind of transition and knowledge sharing. Right? So this is a little bit summarize of what we learned in building LoopBack 4 as a very large-scale project, and I believe it equally applied to any other large-scale LoopBack 4 applications or any other Node.js applications. Okay. As I kind of mentioned, like you really first of all have to settle on the logistics side, figure out how to organize your code base and the share modules. Okay. And that boils down to, what kind of GitHub repos you want to create, and do you want to use one repo or do you use many repos? And the interesting thing here is typically for ongoing project, you don't only just use published versions of your dependency. You could have your internal module A depend on module B. So these kind of intro dependencies are tricky. On one hand, you want to make them independent from each other. On the other side, from build and the testing perspective, you want to make sure they work together at all time. Okay. Now, as I said, for Node.js, it's so easy to get started. Right? As long as you know a little bit JavaScript and you read the getting started guide, you can be very productive right away. And JavaScript is a fantastic language, but this a little bit interesting learning curve. Like especially for me, I come to JavaScript from the enterprise Java background. So there were some traps and some, transitions I have to do to get myself native on JavaScript. Not to mention like JavaScript is single-threaded, event loop-driven, asynchronous in nature, but also, the plain JavaScript does not have the ability to catch the typings and the signatures. So there's no concept of interface and no concept of types. So that works well for smaller scale project. Then we actually learned a pretty hard lesson because once LoopBack was acquired by IBM, then we had a new team, and that new team only have knowledge about JavaScript, but they don't have domain knowledge about API and LoopBack. So we figure out there was a pretty big learning curve, like, because for JavaScript, if you work on that code base day in, day out, you feel comfortable because there are a lot of hidden contracts, right? If you have that history and you can read the source code very well, you probably can reconstruct that knowledge from the code. And sometimes you still have to ask around, like why this and what are the signature for certain things. For example, you have an options object, then you have to read the doc or ask around to figure out what options really are valuable for that particular argument. Okay? And JavaScript also allows you to have optional arguments. So those things are very hard to extract directly from the source code. And we decide to choose TypeScript because of the typing system and the ability to capture a lot of knowledge at coding time. So we kind of pay a tax ahead of time, but that really pays out really well. Number 3, from the runtime perspective, we really want to have a solid and extensible foundation for the Node.js platform for application and the framework developers. And we want to make sure certain proven patterns will be really built into the system. And we continuously and consistently use these patterns to glue our runtime code and then make that available to our developers as well. So that's why the whole framework really bets on the ability of a couple of very powerful patterns. So you already had a little bit sense from what Rifa illustrated to you. So we use a dependency injection framework, and we heavily promote the idea of extension point / extension. Then we also care about the runtime dynamicity by leveraging the listeners and observers, and we actually make the life cycle of the application be part of that story. And since we really handle the request response processing flow, in most cases, you send an API request, the API request get processed and then finally delegate to some database or some backend service that produce a response. Then that response will be transformed into a form that's really compatible and friendly to your REST API. Right? So we introduced the interceptor / middleware pattern that really handles that chain of responsibilities to give that a little bit like aspect-oriented programming without knowing the ugly internals. Right? So following that pattern, you can build middleware. You can leverage existing Express middleware, or you can apply decorators, interceptors for all the methods, not only just on the controller side, but also on the service side to pre and process the method calls. So that gives you the power to do like the caching, validation, authorization. So all these fundamental patterns really is the pillars of the LoopBack 4 foundation. So any questions so far before I break down into different categories and give you a little bit more details? All right, I assume everything's good. So not diving to code organization right away. This is really a dilemma between GitHub repos and the npm package. Right? So we learned a hard lesson in LoopBack 3. Well, like from its beginning to the release of 3.x version. Right? Because we really want to be modular. So a natural choice would be, hey, each GitHub repo would be corresponding to one npm package. Right? So if you look at the LoopBack 3 code base, you will find many different repos. We have LoopBack, we have Juggler, we have all kinds of connectors. So we end up have a very large number of packages and the corresponding number of repositories in Git. Okay. So the first challenge is like, say, if the LoopBack package depends on Juggler and we are making changes on both modules, right? How do we test that out? So we have to sort of like a workaround with that issue by utilizing npm links, which is based on the symbolic link and kind of create that up to date linkage between the two modules. So that's a trick we use. Of course, like when it comes to build and testing, especially under the continuous integration environment, that really becomes a challenge because anytime we fix a bug or implement a new feature that goes beyond 2 different GitHub repos, then we have to create 2 different PRs, and we have to build a Ruby-based build system that recognize the 2 PRs are related to each other. And when it comes to build, it pulls in the 2 PRs and actually build the modules independently and push the build result into a internal npm registry so that the downstream module can consume that version. So that becomes like a black hole nobody can deal with except the DevOps person. Okay. So when it comes to LoopBack 4, we decide to utilize the so-called like a mono repo, right? So mono repo is just one single GitHub repo, and we lay out the code base inside that single GitHub repo so that we have different modules as a subdirectory of that repository. And Nina is one of the best mono repo management capability we use, and we are happy with that choice, even though for many years, like the new options available. So we continue to use Nina at this point. So the idea behind Nina is like you have one GitHub repo, and there's a convention for the repo layout so that the build system can recognize the internal NPM packages and their dependencies so that the tooling can really create the intro dependency that mimic the typical node modules for us, and also have the ability to release the different modules together. And when it comes to CI/CD, the build can really traverse through all the modules and run the build and run the test for that. So that works out very well. Of course, this definitely simplifies the idea to create a PR, right? So now we have one single PR against the same mono repo. Of course, that PR can change many different internal modules which are dependent on each other, right? So that's a great relief. And of course, users can open issues in the same GitHub repo. We don't have to use heavy labeling and some reporting tool to figure out how many issues are incoming, right? As I said, like the CI build will be much more simplified because you treat everything as one single moving part, even though there are a lot of internal components. Okay. So that works well. And on top of Lena, we actually built some additional facilities to leverage the ability to manage that dependency graph. So for example, we create a tool that kind of based upon the dependency graph to figure out the TypeScript project references. Right? So we maintain that project references by this tool so that we can leverage the incremental build for TypeScript that saves quite a bit development time. Okay. So we actually end up release a module that have a collection of utilities we built for Lina that helps you to maintain all the modules all together. For example, we built a script that update the package log.json across the board. We also built some tools that update the copyright statement for all the modules. Right? So those are all very useful tools. I want to mention like npm v7 actually have a new facility called workspaces. And I think it's heavily inspired by Yarn. We try a little bit. It works to a certain extent, especially for the dependency management, but it does not have all the additional facilities to, support the releasing and some other logistic, consistencies across the board. So we haven't, migrated to npm workspaces yet. And I think this whole feature is still being, developed and maturized. Hopefully one day it could be replaced Lina, but I think it's the same idea. It doesn't really matter. I also mentioned because we use TypeScript, and TypeScript now have this ability to define the references across different, npm packages, so that they can understand the change set. If you have a new commit and how many TypeScript files, changed, what are the dependencies. So that gives the system ability to do so-called like a incremental build, right? And we have a tool to really maintain these TypeScript project references using Lina behind the scenes. So I also have 2 links here. If you want to check out, how the things will work. So the first one is the module I mentioned. Like we built a bunch of utilities to help manage the Nina mono repos on top of what Nina can do already. And the second one is if you want to build your loopback for application using the mono repo approach, I create a template. It's a GitHub template, so you can fork from that template to have your own version. So I create this template for the purpose to have my internal project, and I think it works pretty well to jumpstart that effort because it have all the base structure in place. So any questions before I jump to the next section?
So I've got a question about the, I think it's called Learner,
Yeah.
Nina. So we have something similar with how we have a component library for a front end, which we sort of share across multiple front ends to, share the components we build to standardize them. We're doing something with Yalk to, say if we're working on the component library, we want to pull that into a front end. We'd use Yalk to do that. Would we be able to use Learner to do something like that? It's not a technology I've used in the past, so it's quite interesting.
I think they're separate things, Tom. Sorry to interrupt you. I think they're slightly separate things. So I think the equivalent of Yalk is the NPM linking that Raymond was talking about. So that's what you can use for local development to link in one package into another to develop it. So that's where we use Yalk. Learner is to manage multiple dependencies at once if you need to version them all at the same time. So that is something we should have been using in our loopback components. And that's why the project was called loopback components. And then I set it up wrong and it just got dumped with a lot of things. So that's probably what we should have done. We should be having multiple packages in there and we should have used Learner to manage them, which is something I think we should move to in the future.
Yeah, definitely.
Yeah, I think you can actually leverage the best of breeds. Like you can have Nina mono repo and you can still use Yong as a package manager. And I think over time, the community actually contribute quite a bit things that make the mono repo compatible with Yong, especially for the loopback next repo itself. So probably you can check out the package.json and some of the configuration settings. So I think that could be a good combination. So personally, I'm not a Yong expert, so I've still used NPM quite a bit. Yong actually did some experiment to really move into this so-called like a workspace based approach. And I think Nina, Yong, and NPM decided to work together to really push for this idea of workspaces. I think that's a good trend, but as far as I can tell, that feature has the complete parity with Nina yet, and we have been using Nina for many years, and we built tools on top of that. So far, we don't have a good motivation to, force us to switch to NPM workspace yet. All right, any more questions? All right, so let's jump right away. So I already mentioned we built the early versions of loopback using plain JavaScript, and that works well. And you can argue plain JavaScript has less overhead and it gives you the velocity you want to have. But really, we built software for so many years, right? It takes so many iterations, and it actually is a combination of work from many different contributors, and the contribution, the developer can come and go, and over time, the technical debt will build up for the code base. So that's a natural, progression of any software development. And it becomes extremely painful because for JavaScript, there are a lot of like assumptions, hidden contracts, because the language itself is so flexible, right? So as I mentioned, like a lot of like method has the options argument, and that's a little bit like a black hole. So if the developer is disciplined enough to really maintain the JavaScript docs, of course that somewhat eliminate the problem or simplify the issue, but it's hard. Sometimes you change the code, you forgot to update the JS doc, and also when it comes to do refactoring, you move things around, you might easily break things, right? And for newcomers, it's so hard to extract all this hidden knowledge from the code base, or like really have to bother other developers that has much deeper understanding and then much more knowledge about the code base. So that's why like we think as a very sophisticated framework, we really want to use something that can help we stay disciplined and gives us the ability to understand the intention of the code, and also empower developers to use the modern IDEs like Visual Studio Code to do continuous refactoring and make sure the compiler can catch a lot of interesting potential issues ahead of time. So really, it's a balance between how much effort the developer put into the code base versus you want to spend your additional time to spread that knowledge over time without just telling people or documenting that, right? So, as I said, plain JavaScript has a lot of hidden contracts, and for newcomers, you really have to look at the code base and ask around to build up that knowledge, understanding, right? And there's a lot of human dependencies. Okay? If a key developer left the project, then the guy will leave a lot of unknowns to the system. Right? So we decided to adopt TypeScript for LoopBack 4, especially in pursuing to have formal contracts and self-documenting code, and a great IDE support. And since we adopt Lina and we bring that whole system of modules into one workspace, and Visual Studio Code is able to understand all the dependencies as well. So really, if you change one code in one internal module, that could get a big help from TypeScript. And the other interesting feature is now you can really use the content assistant, right? So that's huge. Like really make your development much more simpler. Right? And of course, like from the language itself, we also heavily depend on the decorators. So decorator is a new feature for JavaScript, and TypeScript have early implementation of that, and we actually utilize the decorators to add additional metadata to the code base so that we can leverage this extra metadata to drive some of the runtime behaviors. So that's another thing we decided to use TypeScript as well. And I don't have to really articulate on this. It's very obvious, for a newcomer, you will find the second one seems to be more complicated at the first impression. But if you have to maintain that code, you will probably love that. And nowadays, when I work on any, NPM dependencies, especially say I have to work on many different kind of SDKs that talk to different blockchains. Some SDKs does have the TypeScript definition, and that really helps me to learn quickly. And some, SDKs does not have the TypeScript definition. Then I have to really look at the documentation and go to different discussion groups to figure out, what I can do there. Right? So that's to me, like TypeScript and really forcing the developers to think about the usage ahead of time and capture all this knowledge as much as possible. It's a big investment, but personally, I feel for any large scale project, that investment definitely is worthwhile, and it will benefit you for many years and for many different teams and the developers. So I won't spend too much time between a JavaScript and a TypeScript. Your opinions may vary, but for large scale project, I personally fully and strongly recommend to use TypeScript. Next section. So now we have a mono repo to manage so many packages, right? And we decided to use TypeScript to catch a lot of knowledge in the code, so that other tools can help us to spread that knowledge and enforce some of the constraints. Then when it comes to the real world application or framework development, there are additional challenges beyond the logistics stuff, right? Using a TypeScript doesn't mean you will write clean code. You write modular code, right? So we decide to put together a code foundation that deal with some of the challenges we have been facing over time. The first one would be we will have a lot of different artifacts in the system, right? And oftentimes the artifacts depend on each other. Right? So in the REST API story, we typically have a controller that handles the JavaScript, TypeScript to REST mapping, right? Then the controller usually just be the facade, but the controller might depend on other services to do the real API logic. It may talk to a database or a backend service, right? So that means the controller itself as an artifact, it may have dependency on a repository, which represent the database connectivity. It might have dependency on a remote service that represent remote sub web services. So for the artifacts, your runtime should have the ability to find the artifacts. So for JavaScript or TypeScript itself, typically you will think about require and import, right? So require plays two different roles. One is finding the dependency artifacts by name, and the second one is really loading up the dependency module. Right? So that works well for simple project as long as you know the dependency tree ahead of time. But really that dependency is being hard coded in your module. Right? And sometimes the dependency want to come in at runtime, or you want to lazily load up that dependency. So the import statement or the require statement force you to resolve the dependency ahead of time. Okay? And you really cannot require certain things by the interface. You really have to resolve and require at the same time. So that's one angle. The other angle is the typical pattern would be just require and import that. So that's a little bit like a lookup, right? And of course, you can improve that by providing a registry, so you can look up the artifacts by its name or by some search criteria. But the other option is you really apply the inversion of control, right? So you have the container to figure out what resolved dependency should be and make that resolve the dependency available through the constructor or through the property injection. And in our case, sometimes the injection can happen at the method argument level, right? So those are the different things we look at it. And we actually build up the LoopBack 4 core as a inversion of control container. So it plays a couple of different roles, right? So the container itself is a universal registry. No matter how many modules you have, how many components you have, even you could have multiple applications work together. you can all contribute, artifacts to this universal registry. And this also help us to eliminate the need to have different registries for different artifacts. So in LoopBack 3, for example, we have a registry inside the database juggler. We also have a registry in the remoting module, and we also have registry in the LoopBack main module. And oftentimes we have to go across the different registries to do the work. So this universal registry really reduce the complexity and give us a global knowledge about different things. Okay. And secondly, we create the so-called like a binding. Binding very much like one entry in the registry, and each binding have a unique key. And the bindings also can have additional metadata as so-called like a tags. So basically, it's very much like additional attributes to describe that entry. So the tags are pretty powerful to give us the ability to discover and dynamically, resolve and inject dependencies. Dependency injection is a pattern beyond just a service locator, right? Instead of have the application code to proactively look up the dependency, we could have the container to reversely push the dependency onto your code. As I mentioned early in the question, we really paying attention to so-called like asynchronous dependency injection, because in JavaScript, Node, a lot of dependency can only be fulfilled asynchronously. For example, you look up things from the database, you call an asynchronous API. Those things becomes really independent, like asynchronously depend on each other. Right? But some constructors, like the constructor itself, is synchronous in nature. How do we achieve that asynchronous dependency injection? So we look at all the arguments of the constructor, and we actually fulfill all the argument resolution first asynchronously before we instantiate a new class through the constructor. Right? So that's how we achieve that. And we also introduce the idea of value of promise to really keep synchronous interactions sync and asynchronous interaction async, and the mixture of synchronous interaction and the asynchronous interaction becomes asynchronous in nature, right? As long as there's one single step that requires asynchronous interactions. So this diagram kind of shows how we bind the different artifacts into the system using the bindings and give each of the entry a unique key. Right? And then when it comes to resolution, you have two ways. One is you directly use a lookup pattern to get that dependency by the key, or you could have the container to push that dependency to the receiving artifacts. Right? And in this case, we kind of illustrate the different ways of doing things. Right? So the user controller has dependency on user registry, and it also have a service dependency on the password hasher. Right? And to replace the password hasher with a dependency injection, everything becomes so simple. You just have to, bind utilities password hasher with a new version. Then, the code in the user controller, you don't have to make any changes. Right? It just naturally happens. When it comes to dependency injection, you sort of have to declare that dependency, right? And that's where the decorator is coming to play. So decorator basically is a function applies to the class construction. Right? So it can happen at the class level, it can happen at the property level, it can happen at argument level. And the argument level could be for the constructor or for the regular methods. Okay. So and to allow the injection, we actually have the asynchronous version, we have the synchronous version, and we also have optional dependencies, so that you get the different mixture of different nature of dependencies. I believe Rifa kind of cover a lot of things about the dependency injection, and we also have a lot of good examples in the code base to cover dependency injection. And our dependency injection framework is really powerful. There are a lot of different advanced features. Like for example, we built the registry as a hierarchical context chain so that you can share the different artifacts at different scopes. So one typical example is you have the application, right? So you have a lot of application level artifacts. Then we also have different kind of servers. We have a REST server, we have a GraphQL server. You could even have gRPC server. So server is a child of the application. You could have multiple server instances that share the same application instance, right? And of course, like then when for every single request coming to a given server, we actually build a child context of the server for the request. And in the request context, you have a lot of knowledge about that particular request, like who's the caller, what's the URL, and what's the target audience. Right? So you can do a lot of like a personalization or like a security checks as part of the request. So having the ability to form a hierarchy for all this registry gives us the ability to share and isolate different bindings. And that gives us ultimate flexibility. For example, at context for the request level, you can swap out different things. And that's how we achieve, for example, the so-called like context propagation as well as multi-tenancy, because depending on the incoming request, you can decide to rebind some dependencies for that given request. Okay? So that gives you the ability to access the state of the request as well as swapping out. For example, user A use database A and user B use database B. So we can achieve sharding using that technique. Okay? We can achieve multi-tenancy for that technique. Okay? Basically, if you swap up a given binding at the request level, and when you resolve that dependency at the request level, it overrides the default binding coming from the server level or from the application level. Okay? So that means really any single request could have its own scope that declare the dependency tree. Okay? So for the sake of timing, that's unless you have any questions, otherwise we can jump to the next session, which is extensibility, which is a continuation of the Artifactory registry discovery and the dependency injection. Any questions?
I have some questions from Matt, who's had to unfortunately jump off the call, but I can leave them to the end if you prefer.
Okay, that's fine. So let's just finish the slides, and we can have a little bit Q&A there. All right, so Rifa just illustrate a good example of leveraging extension point and extensions to make Prisma, into the LoopBack ecosystem. And I think he mentioned a couple of the requirements, like say, hey, how we handle Prisma configuration, how to deal with some of the Prisma artifacts. And we actually have a example application which kind of handling the multi-language grading. Right? So you can grade in English, you can grade in French, you can grade in Chinese. How we make sure like any incoming HTTP request will receive a different version of the grading, so that really going to the direction of like extensibility. Right? So you don't know all these different language implementation of the grader ahead of time, but at the runtime, you want to make sure it leverage the accept language HTTP header to figure out which grader to be used. Right? So that's really the simple use case for extensibility. And of course, like all the different authentication strategies, the service delegation, the multi-tenancy, all requires on to have the extensibility. Right? So that really based on the idea we have so many artifacts, and oftentimes you can have a group of artifacts that contribute the similar behavior with a different implementation, right? So that split the responsibility into so-called extension point and extension. So extension point is the common logic that understand the common contract and do the delegation. And extension is a specific implementation of the same interface that really provide the same behavior using different techniques, right? But the coupling between extension point and extension could be really separate because the extension point does not have to know all the extensions ahead of time, and extensions does not have to tie it back to the extension point except the contract itself and the discoverability. So those unknowns need us to build a good pattern called extension point and extension, so that we can have that collaboration happening dynamically at runtime. So this is one example, which is the authentication component, because we may have different authentication schemes. So we want to create that abstraction. Each of the authentication strategy can do, right? So we have an extension point, which really handles the incoming authentication request and figure out what scheme we should apply the authentication and delegate to the corresponding authentication strategy for different kind of authentications, right? So we could have auth2 authentication, we can have LDAP authentication, we have a user ID password-based authentication. So this pattern allows us to group these two different kinds of artifacts together and achieve a goal collaboratively. We can explain a little bit how these two things are being bound together, right? So we set each entry in our IOC container is a binding, right? So extension point itself is a binding, and extension point have a name or ID, right? Then for each extension, we have its own entry. So typically, your extension will tag itself as an extension for a given, extension point, right? For example, in a grader case, we can say, hey, I have an English grader, but this is really an extension to the grader interface or the grader extension point. Then when you add a new grader in Chinese, you can also tag that binding with the same tag. Then when it comes to runtime, the grader extension point can discover all these entries from the global registry and resolve them and inject them into the grader component. Then the grader component will check the incoming request for the accept language header and figure out, based upon the header, which grader should be used. Right? So that's how things get tied together. Of course, like from the packager perspective, you can actually have different modules for different extensions, or for different, for example, we have a couple of extensions in LoopBack for cloud native support. Like you have a login, you have metrics, you have things, so you can package them as a component, and that component could be registered to your main application. Then that component could contribute artifacts, including extension point or extensions to the system. Okay. So this is the example I was talking about, like how you build a fancy hello world that recognize the language requirement, and this shows a little bit like the dependencies as well as how we separate the code into two different modules, and then you can actually find the code, play with from the GitHub repo. I have a link here. Okay. So if we look at here, a couple of things involved. We have an incoming request to the REST server, and the REST server could be look at the cache layer. And for this case, we actually add a caching interceptor between the REST server and the grading controller. So the caching interceptor really can find the cache in the caching service, right? And the caching service can have a configuration to decide, how we're going to keep the cache in place. And we might refresh the cache in the background. So that's why we sort of have a cache observer that clean up the expired entries periodically. Right? So those kind of a good illustration of the different plugin point. You can add logic to the LoopBack for application to do the job either horizontally or vertically. Right? Then for the grading controller itself, as I said, it will delegate to a so-called grading service. Right? Then the grading service becomes the facade to many different graders. Right? So that's how the extension point recognize the different kind of extensions and utilize the accept and language header to figure out which grader it should delegate to. Okay. And the grading service does not have to know the English grader or Chinese grader, and the Chinese grader does not have to know the grading service, except they have to implement the agreed interface and the register itself with a binding tag that helps the extension point to discover them. Okay. So that kind of concludes the extension point extension pattern. This is a very powerful pattern we use again and again, and I would strongly recommend to dig into that and use that in your application itself as well. Okay. Any questions?
I have a question around sort of further reading documentation on this. Is there quite an extensive amount of documentation on this on the actual LoopBack website? Or is the pattern quite a general one we could research thoroughly elsewhere? Or?
Yeah, so I think it's both. First of all, the extension point action pattern really coming from Eclipse. So I was a big fan of Eclipse, and I especially like the idea to have that plugin system, which is really just a Java implementation of the extension point / extension pattern. So we brought this pattern to TypeScript. So the principle is the same. Really, it's a decoupling between the common logic from the specific logic and make them bind together at runtime based on the agreed interface and the binding tags. We also have documentation talk about extension point extension. So toward the end, I have a link to the tutorial we built, and we also explain what is the context and what's the ability of the context. And on top of that, we specialize pattern for extension point extension. So basically, it's the same idea. Like when you register extension, you give that binding some special tags to decorate the extension. Say, hey, this is really extension for the greater extension point, right? And then at runtime, we utilize the dependency injection. We have the specialized injector, which is a customized version of add injector. So we have add extensions to describe that dependency so that the runtime will follow that extension point extension pattern to resolve all the extensions and makes the extensions instances available as a dynamic view or as a resolve snapshot to your application. So if you have specific questions, feel free to bring up that to the Slack channel we have. We are happy to answer there as well.
Brilliant, thank you.
Right, so I still have a couple of slides, so let's try to finish that in time. So kind of going back to this diagram, right? So we already talked about the ability to intercept the request response processing and do something meaningful in between, right? So that's how we actually go into the next topic. We want to have a chain of responsibilities. So I assume a lot of you are already familiar with Express middleware. So one of the caveat of Express middleware is it's not a chain action. It's actually find and forget. So you have a request coming in, you do some processing, then You just pass to the next one, but you don't have a good influence how to trigger the next one, and you don't have the control whenever the next one produces a response. So in Express, for example, the logging middleware, they have to use some workaround. For example, the logging component, the Morgan middleware, they have to use an event on the response object to understand if that response has been produced, so that you can do the second step of the logic. But for us, we really want to have that cascade, interception, just like Covéa does for the middleware. So the upstream interceptor can decide if they want to proceed to the next one, or they can do pre-processing and post-processing using a very simple, building block, right? And you can even use a try catch to handle the error situations. So like caching is one of the interceptors you can do, right? And of course, authorization could be modeled as an interceptor. So that sort of like becomes a chain of responsibility. We put some efforts to build this interception chain, and the interception chain give us the ability to do cascading style of invocations. That means the upstream interceptor have the full control on how to invoke the downstream interceptors, and also being able to handle the response and the errors after the downstream chain finishes execution. And we also build a wrapper so that the typical Express one-way middleware could be play a role in the middleware chain. So we have divided the chain into two different places. One is between the REST server and the controller. Right? So we go through a bunch of middleware that really understand the REST API call to do the raw, finding the corresponding controller, and then build up the argument list, performing authentication, rate limiting, and any other Express middleware you want to do. Then once we figure out what controller method to invoke, as part of that invocation, we also can have a specific interceptors on the controller itself or the controller method itself. So that gives us the ability really to target a particular controller method or a couple of controller methods. So for example, the voter-based authorization could happen on that fashion because before the real business logic is being invoked, we can actually check if the caller has the permission to do so. And the caching can happen at that level as well, because if you have a heavy-duty API call that produces response and you want to cache that response without forcing the application code to write that repeating logic all over the place, you can have caching interceptor that really handles that caching automatically for the application. The other type of responsibilities, for example, we have a so-called like a application booting, right? Application booting basically discover artifacts from the file system following certain patterns. Then we coordinate the life cycle. Right? So that's also a chain of responsibility, because when it comes to boot, we have a main bootstrapper, and then the bootstrapper discover the different kind of booters as extensions, and we divide that booting process into a couple of phases. Right? So you can discover the artifacts, you can load the artifacts, then you can configure the artifacts and resolve the artifacts. Okay. In addition to the interception-based approach, we used to have a functional composition-based approach, meaning you can have one function calling another function that kind of composes things together. Right? So that's the ideas behind middleware and the interceptors. So up to this point, we very much talk about the core foundation we built for LoopBack 4, and that really puts other things, aside. Meaning, you really don't have to use LoopBack to build REST APIs, and we actually use LoopBack to build many different types of applications. I personally built, COI applications using LoopBack. We build server-side applications using LoopBack. I even build applications inside the browser that utilizing LoopBack. So really, the core foundation is the base platform that helps build large-scale, applications or even, frameworks yourself. And another interesting thing is we have a LB Open API, command line tool that helps you to build a SDK from your REST APIs. And the SDK itself could be a LoopBack 4 application, right? And you can use the SDK on the server side as a Node.js module. You can even use the SDK inside the browser as a ES6 module inside your React, Angular, Servlet, application or just a plain application. So we have a Webpack bundle for the LoopBack for core runtime as well. So the tutorial linked here really gives you the complete knowledge about why we need to have this foundation and what you can do with this foundation outside of the context of building APIs and microservices, right? So feel free to check it out and bring questions to the forum if necessary. Let's see. Yeah, so I think that's pretty much I want to cover today. I sort of have to fly around quite a bit, and there are a lot of things behind that. But again, once you have this basic understanding, bring discussions to our GitHub repo, bring questions to the Slack channel. That would be a good place to really understand the different use cases and why we have different kind of abstractions to support that use case. Okay. So as a summary, now you sort of understand what it takes to build a larger scale Node.js application using the experience we built LoopBack and use the LoopBack core foundation as your base platform. So we really want to scale your code base with modularity, but you don't want to sacrifice by introducing a lot of complexity. And of course, you want to pick the right language and the right IDE to boost the productivity of your developers and make sure the knowledge can speak itself in the code. Then you want to have a good runtime, and that runtime really avoid any repetitive work you have to do. So that runtime should have some proven patterns, and these patterns will help you go a much long way. And of course, like for your project, for your application, you want to make sure the users have a consistent convention, the coding style, and you might want to build like CLI tools or UI extensions to really support them journey. Right? So adopting a framework should be a helper, should not be impulsive. But we want to make sure you can do simple things easily, and you should be able to do advanced things without being trapped by the framework. So that's a good balance we want to strike here. Of course, like there's definitely room for improvement, and we would like to hear your use cases, hear your feedback. That would be a great win-win journey we can go together. All right, so that's pretty much all I have today, and I think we still have a little bit of time for Q&A.
Thank you so much. That was an amazing presentation from all of you, and we've definitely got a lot of stuff to talk about within Covéa, and hopefully you see most of us in your Slack channel as well in LoopBack to continue some of these conversations. So I do have some questions from Matt Lishman, okay, so the first question was for Rifa. And
stop sharing.
Yep.
Okay, and that question is, sorry, I'm just trying to find it. Okay, so how do you balance your work life with contributing to LoopBack's core? And is there a process you could sort of suggest around that?
Oh, okay. I think it's a rather interesting question because typically that is usually not what people ask, but I think it's a really good question nonetheless because of course, if you want to contribute to open source, how do you do it in a feasible and sustainable manner? I mean, every organization, every individual is different. From my end, I do support my organization in building internal applications, and we heavily leverage LoopBack 4 as a framework, not only in terms of web APIs, but also for some internal extensions as well. So like we build CLIs with it as well, and because we can leverage knowledge we use as a result of that. Because as mentioned before, some components, quite a number of components of LoopBack 4 isn't REST oriented. So we can do that as well without making it seem like a shoehorn. As for contributing to LoopBack 4 itself, for us, at least from my end, because we use LoopBack 4 as a framework quite extensively, we actually benefit we have this kind of like feedback loop where we benefit from contributing back to the framework. So anything that we see that is a potential miss from our end, we can work with the community. We see this as an opportunity to work with the community to contribute back upstream. So for example, with Prisma, as part of LoopBack 4's philosophy, we're not opinionated. We don't want to force people to use a single ORM. So for us, we also kind of use Prisma for some of our projects, but it's kind of tacked on. It's they're using like a native extension for it in LoopBack 4. So we decided, okay, let's perhaps start an open contribution for Prisma, and that's what we're doing right here. And this is not only just this actually benefits us as well because of the open model, we're able to get feedback from other users, people who want to potentially use the framework, from other maintainers as well. And this also gives us the opportunity to kind of experiment with new features of LoopBack 4 that we may not have used otherwise. So like internal projects, we tend to play a bit more safe if we're not too familiar with certain concepts. But with this, we can actually try out new features as well because it's an experimental package, and then hopefully eventually we can mature it. As for balancing time between contributing back and other work-life balance, at least for me, I'm in a thankful position because as for my organization, we are able to actually segregate some time to contribute back to the project. As for larger organizations, I believe there is what they call the to-do group. I believe it's called the to-do group. Essentially, the to-do group kind of like focuses on writing materials on how to manage like a open source contributions and an open source strategy for organizations. So perhaps that could be useful for you guys as well. At least for me, I've personally not needed to use this resource, but there's quite a lot of healthy discussion, especially in Slack, discussing like how different organizations react and support these projects. So in the end, the way we see is that LoopBack 4 is a community project. If we contribute back to the project, we support them. If we support the community via Slack and Stack Overflow, we're kind of like helping nurture an ecosystem that is sustainable for the project in the long term, and that will help benefit us as well. Because then we get more people on the project, more eyes on it, and hopefully more bugs are found, more bugs are fixed by the community, and maybe new features are requested, things that we may not have thought about. So in the end, that's kind of how we justify, because it's a positive feedback loop in all.
Yeah, that's definitely something we could consider giving sort of time towards if we wish to extend LoopBack ourselves. We currently do have sort of time to do self-learning every week, so I'm sure we could integrate that with something like this in the near future. So another question, and this is more of a general for everyone. So how do you keep LoopBack up to date, and how do you maintain keeping keep LoopBack services and its dependencies up to date constantly?
Yeah, so that's a good question. Like we automate the dependency update using a renovate bot, and that actually helps us quite a bit because when the bot discover new dependencies, they create a CI jobs that try to apply that new dependency and also have the ability to divide the dependency into different levels. Like for example, you could have patch level, minor level, or major level, and also gives the ability to group a bunch of dependencies together, so they will apply the dependency changes in one PR. So, and we try that initially to require a manual approval, and over time we figure out some of the patch level or minor level dependency upgrade could be happen automatically. So we enable the auto merge features to make sure if the CI is green, we have a good confidence all the dependency upgrade will be healthy. So we apply that. But for major dependency upgrade, we still have to have a approval from the maintainers, and some dependencies will break, and we pay attention to these breaks, and we try to fix that as we go, because not all the dependencies strictly follow the semantic versioning, and even between the different version of TypeScript, it introduce breaking chains. So we just have to be proactively looking at the CI build features for these new dependencies and fix them as we go. So this gives us a good, cadence to make sure we stay ahead of time and make sure all the dependencies are being, up to date if it does not break the current code.
It's a really good answer. Thank you. That'll give us some stuff to think about how we can manage that in the future as well. So I have a question about backwards compatibility and maintenance of backwards compatibility. So say if we generate a loopback project 4 months ago and we want to upgrade that to the current date of sort of the loopback project, is there a more automatic way we can do that, or would we sort of had to compare the differences between the time scale and upgrade each respectively?
That comes with twofold. One is when we release LoopBack 4 modules, we really pay attention to the breaking changes. And if we ever have to introduce breaking changes, we use a so-called like a conventional commit to catch all these breaking changes. And the Nina build system will automatically adjust the new version number based upon these conventional commits. So that's on our side. On the application side, we build a COI tool called LB4 update. So that kind of get a knowledge of a new release as a whole, because we have so many modules being released together, and that's the greatest confidence we could have if you upgrade to the same level modules from one single release, right? So the COI will have that knowledge, and when you run LB4 update, it can prompt you to upgrade all your dependencies altogether. But of course, that does not guarantee your application won't be broken. So you still have to make sure you have enough test coverage to ensure the health of your application when the dependency changes. So if you have that good test coverage, then you can use LB4 update to update the dependencies. Then you can run your integration test again against the application. If everything is still working fine, that's a good sign the dependency upgrade didn't break your application.
Yeah, so just to extend from what Raymond has mentioned, for LoopBack 4, historically, we have not actually introduced that many breaking changes, and if there's any, it's mostly in the experimental packages. The only thing that can probably get out of sync is like the generated artifacts, like the VS Code workstation settings or ESLint configuration. But maybe we have updated it to be a little better. But I wouldn't consider those breaking changes if because you can always update them manually if you need to. And as Raymond has mentioned, there's the lb4 update command. So because all of the dependencies are actually, the loopback dependencies are actually stored on the tagged on the CLI version. So if you share the same CLI versions, if you use lb4 update across the board, it will use the same dependency version range. So that will help like keep every dependency in sync.
Brilliant. Thank you for answering that. Does anyone else have any more questions? You can either put it in the text or shout out. No, okay. I think that's it from us then. Perfectly on time. I'll start the recording now.